Howdy everyone, it's Miss Kosh. I am going to work through these 3 example problems on right triangle application. So here we go. The first thing that they want us to do is, I put this together. The first thing I want to point out to you is what the angle of elevation is and what the angle of depression is, okay, and what it's not. So we have this pilot is flying the plane, and he or she, whatever. My dad was a pilot. We'll use my dad. My dad's flying the plane, and he looks out the front window, and he's looking just straight. His eyesight is parallel to the ground, and so then he looks down, and he sees the control tower. Okay, this angle right here is the angle of depression. Okay, the biggest mistake kids make is that they would say that this is the angle of depression. No, that doesn't have a name. Those two would add up to 90, so it's the complement of the angle of depression, but it in and of itself does not have a name. So we never use that particular angle. The angle of elevation is when somebody is at the control tower and they look up and spot my dad. And you'll notice that these two angles, those are alternate interior angles if you remember your geometry. Since the pilot is looking in such a way that it's parallel to the horizon or parallel to the ground, those parallel lines give you congruent alternate interior angles. So this one is the angle of depression, and this one is the angle of elevation. And sometimes we'll notice that the height here on this side, this height matches the height from the plane. Okay, so sometimes it's helpful to use this triangle, and sometimes it's helpful to use this triangle. It just depends on the situation. But they are in fact the same triangle. I mean, they're congruent triangles that are just kind of rotated. So, I mean, they're not the same triangle, I guess, but they're congruent. Okay, so let's look at that first. The first problem kind of deals with this sort of thing. So on this very first problem, they say an airplane pilot, so my dad, spots a control tower at an angle of depression of 47 degrees. So that means that this is 47 degrees. Technically, we should label it. I should have put degrees, but whatever. He knows that his altitude is 30,000 feet. So that means this is 30,000 feet. That means also this is 30,000 feet. What is the ground distance from the plane to the tower? Okay, so we're looking for this. So we can, it's also this up here. So you can use the top triangle, you can use the bottom triangle. It doesn't matter, but I'm labeling both of them. So I see that I've got an angle, and here's the opposite, and here's the adjacent. Opposite and adjacent means tangent. Okay, so that means tangent of 47 is equal to 30,000 over x. Okay, so now x would equal 30,000 divided by tangent of 47. This, by the way, is the exact answer. Sometimes my kids struggle to know what I mean by an exact answer. An exact answer is what you come up with without the calculator. The exact answer, you haven't had to round for a weird tangent or round for a weird radical or do any sort. You haven't done any rounding. That's the exact value. The approximation is definitely more relevant. Like, we don't really care. Like, well, if you told somebody, oh yeah, you're 30,000 divided by tangent of 47 feet away from the tower, they're going to think you're crazy, because you might just be. So we're going to plug that in our calculator to give them an idea of what the actual value is. Don't forget to put your calculator in degrees. And so this becomes, and I think we're rounding mostly to the third decimal place, and these are in terms of feet. Okay, there we go. The next one, a flagpole is on top of a building, 300 feet from the base of the building. The angle of elevation to the top of the pole is 33 degrees, and the angle of elevation to the top of the building is 31 degrees. Sorry, I should have said that. Find the length of the pole to the nearest tenth. Okay, so here's my building. I'm a really good drawer. That's a total lie. And here's my flagpole. There's my flag on top. And so somebody is way over here, Can you see them? Okay, so flag, building, you're gonna do enough. So they're 300 feet away. The angle of elevation to the top of the pole, so this to the top, is 33, and the angle of elevation to the bottom of the pole is 31. So this angle here is 31, this angle is 33. So you have a few options for how you think through it. Basically, what we're looking for is, let's call this P for pole. And you could call this B for building, and this whole thing, oh, that's a funny looking, I can do better than that. This whole thing is the T, the total. Okay, so notice we can find the pole, which is what we're looking for, is going to be equal to the total minus the building. Okay, so sometimes it's necessary to set up a system. This one, not so much, because we know that the total is using this triangle. It's a right triangle. Can you see what I'm trying to draw? Okay, that one is tangent of 33 is equal to t over 300. So tangent of 33 is equal to t over 300. Therefore, t is equal to 300 tangent 33. Now let's look for b. Tangent of 31. That's actually, hang on, let me use a new color. That would be this triangle. Whoa, okay, I didn't draw, but okay, pretend I can draw straight lines. You see what I'm trying? Okay, now I'm just making it worse. So that one is tangent of 31 is equal to b over 300. So b is equal to 300 tangent 31. So now, since we're going to subtract those two, if they asked for the exact value, which we've been known to do mean things like that, you would just say, okay, the exact value is 300 tangent 33 minus 300 tangent 31. Once again, not very relevant. Like, that doesn't tell me anything about the real world. 300 tangent, I'm using a calculator that you can't see, but, you know, I am. Tangent 31. And that is, the pole is approximately 14.564. What were my units? I think they were feet. Okay, so far so good. The next one, while taking a ride in a hot air balloon, Taylor wonders how high she is. To find out, she chooses a landmark that is to the east of the balloon and measures the angle of depression to be 54 degrees. A few minutes later, after traveling 100 feet east, the angle of depression to the same landmark is determined to be 61. Okay, so here's Taylor in the balloon at first. That's a balloon, and there's the basket underneath. I'm telling you, I'm an amazing artist. That's a lie. Okay, so she sees some landmark down here on the ground. So here's her angle of depression. Always is based off of that parallel line to the horizon. Okay, and so initially. Okay, initially, what did it? She chose. It's east of the balloon, and it measures an angle of depression to be 54 degrees. Okay, a few minutes later, after traveling 100 feet east, so she has gone in the direction of that object. Okay, so now here's her balloon. She finds that the angle of the depression to the same landmark. Oh, pretend I can draw a straight line. That looks kind of terrible. Okay, that's 61 degrees. Now use this information to determine the height of the balloon. Okay, so this is h that we're looking for. We know that this is a right angle. So what and we know that she's gone 100 feet here. So at this point, we are going to need to use a system of equations, which is good that I'm giving this example to you. We'll call this as some other variable, call it x or something. Okay, and so now I've got two triangles that I care about. The first one being this. Okay, and in that particular triangle, I will say that tangent of 61 is equal to h over x. And then I also have, oh, that's this, okay. And then I also have, I want a new color, this triangle. Okay, that triangle. And what I know about that triangle is that tangent of 54 is equal to h over x plus 100. Okay, now I have two equations with two variables, and so I can solve my system. Sometimes one way is easier to work than the other way. On the homework, I did different things so that you could kind of see. There was one problem I worked it twice, so go find my second method on page 4. Okay, so for the homework. A few minutes later, let's see. Use this information to determine the height. So what we care about is finding h. Now, to be honest with you, oh, this, by the way, that's the green. Okay. This will be easier to find x first and then use that to solve for h, but it doesn't matter which way you do it. So each of those, I want to solve for a variable so that I can then do substitution, set them equal to each other. I think it will be easier for us to say that h is equal to x tangent of 61 and h is equal to x plus 100 times tangent of 54. And so now those two things can be set equal to each other. And so I can say x tangent of 61 is going to equal, I'm going to distribute at the same time, okay, and now we've seen problems that kind of resemble this. We keep seeing this sort of a scenario, and then you have to factor it out. Remember how we've done that? If what I just said doesn't make sense to you, let me know. Okay, so I'm factoring this out. I'm getting emails while y'all are taking your quiz right now, so we'll see. Hopefully you're not freaking out about it. Okay, but I'm going to finish this problem. Okay, so there we go. So we found that x is exactly equal to that. But once again, they didn't ask us we don't really care what x is equal to. We care what h is equal to. So it looks to me like I could take this right here and plug it back into, that might be the easiest one. So I have this is my exact value. So to find, well, let's find, that's the exact x. To find the exact h, I know h is equal to x tangent 61. I just solve for x. All of this gets multiplied by tangent of 61, which means you could put tangent of 61 in the numerator. Like, so I can go to my calculator and type in this. That's perfectly a legitimate way to write that. These are both exact. And so now I'm heading to my calculator. 100 tangent of 54 times tangent of 61 over tangent of 61 minus tangent of 54. And I find that my height, Taylor, is approximately 580.607. What were my units? Feet. She is that many feet high in her balloon. Okay, hopefully that was helpful. This is definitely stuff you've seen in geometry, but we definitely want to make it a little more complicated. And yeah, let me know if you have questions. Go practice.